And final talk of the day, we have Oriana Chafe with the PNW Research Station.
Hello, my name is Oriana Chafe, and I'm an ORISE Research Fellow at the Pacific Northwest Research Station and a graduate student at the University of Oregon. And today I'll be sharing a project that I'm working on with my mentor at the Pacific Northwest Research Station, Jeremy Freed. And we're looking at 20 years of post-fire recovery in Western Oregon using a spatially balanced forest inventory sample. So while we all, I think in this room, are aware that we know a fair amount about the post-fire trajectories of frequent fire ecosystems, our understanding of post-fire landscape is less refined for systems like the West Side, where fire is relatively frequent occurrence. So this work focuses on how variability of the pre-fire forest conditions influences fire behavior and how fire behavior shapes the immediate post-fire landscape. And then putting that into further context, how the post-fire landscape develops over time, such as by returning to pre-fire conditions following the expected successional trajectory or deviating onto an alternate trajectory. Now, this is challenging to study because these systems are hard to predict exactly when, where, or where not a fire might occur. And so that gets an interesting challenge that we have of trying to get pre-fire data to compare post-fire ecosystems to. So by integrating annual forest inventory and analysis data, like explained by Jeremy earlier this morning, that has been collected over 20 years with prior periodic inventories, like the current vegetation survey, which goes back to the early 1990s, we're able to look at the post-fire trajectories of plots that have burned over the period of 1994 to 2018 and have both pre-fire as well as 2 to 3 post-fire visits. And I'll say that while linking annual and periodic inventories is no small challenge due to differences in sampling protocols and plot designs, we're able to utilize the portions of the various plot footprints that overlap to look across time at these sites. And so for this project, we first conducted a spatial overlay of all periodic and annual forest inventory plots within the fire perimeters throughout Western Oregon and Washington. Today I'll be focusing on Western Oregon. And we then subsetted these spatial overlay to only include places that had either had pre-fire inventory data as well as 2 to 3 post-fire visits. Hence why I won't be covering anything about the 2020 fires. Sorry, we don't have post-fire data yet. So our data set contains roughly about 340 plots that are within the perimeters of 70 fires that burned throughout Western Oregon in the period of 1994 to 2018. And these plots span the Western Cascades and the Southern Oregon region, with approximately 60% of these plots located down in the Klamath ecoregion and 40% in the Western Cascades. And almost all of these plots are located on public land due to the periodic inventory sampling designs. So for today, I'll be highlighting a case study focusing on the 2002 Biscuit Fire Complex. And the periodic annual database that we're assembling includes approximately 180 plots that were burned in the Biscuit Fire, with pre-fire data from an average of 5 years pre-fire. And then over the first 1 to 2 years following the fire, these inventory plots were sampled through a supplemental fire effects survey. And then subsequently, these plots were censused as part of the annual FIA program, where each plot is visited every 10 years. So we have 2 post-fire measurement windows spanning 2 to 8 years and 8 to 18 years post-fire. So first, we'll look at the fate of individual trees through the post-fire period. Here we've got the proportion of trees that survived the fire, broken down by size class. We see that the survival rate was higher in larger diameter trees, with a median survival of 0, 33, 76, and 100% for trees that are 1 to 5 inches, 5 to 9 inches, 9 to 20, or greater than 20 inches, respectively, moving from left to right. However, when we continue to track these trees throughout the post-fire period, we see that delayed mortality plays a part. no small surprise after the previous panel. And the overall survival rates drops from a median of 38 to 31%. And I'll say as a quick caveat that a subset of trees were not able to be reconciled through the change in inventory protocol, so they've been excluded from these estimated survival rates, but we don't expect them to significantly impact these estimates. So now scaling up from the individual tree level to the stand level, we see that stand composition is an important component, as approximately 3/4 of the stands that had been dominated by softwood conifers pre-fire lost less than 25% of their basal area. But in comparison, approximately 1/4 of the hardwood-dominated stands lost more than 75% of their basal area. And while this makes sense from a fire resistance perspective, it doesn't take into account variations in the post-fire regeneration strategies of these different groups. And so now we'll shift and start thinking about how forest structure changed over the course of the post-fire period, taking into account the cumulative effects of both delayed mortality and regeneration on a plat level. So to start, we're going to step through these graphs from left to right. And on the y-axis, we have trees per acre, and on the x-axis, the temporal sampling period. So the shaded beige area denotes the change from the pre-fire to immediately post-fire period, while the unshaded area includes the two post-fire sampling periods of 2 to 8 and 8 to 18 years. So we have softwood conifers on the top and hardwoods on the bottom, and the individual lines show what happened at each plot, whereas the black line denotes the mean. And the listed proportions in each box indicates the direction of change from immediately post-fire to that last post-fire measurement, and shows how many plots either increased or decreased or maintained their post-fire tree density over those subsequent 2 decades. So for the 1 to 5 inch size class that we have here, we see that there's the variability in regeneration strategies plays a part in the initial post-fire landscape, as even though both tree types were reduced to approximately 50% of the original trees per acre, over the course of the post-fire period, hardwoods began regenerating into this size class and regained 96% of their original TPA value, whereas conifers remained down at approximately 20%. So next we move into the 5 and 9 to 20 inch size classes, and we see that medium-sized trees continue to decline on average. Some softwood plots increased over the course of the post-fire period, likely low-severity plots with trees that matured into this size class, but overall medium-sized trees continued to decrease in density. And lastly, with the greater than 20 inch size class added in, ultimately these larger 3 size class maintained approximately 50 to 70% of their original tree density, with the exception of very large hardwoods, which did not fare very well. So tying it all together, these data show that the immediate and delayed mortality affected trees and stands differently depending on their size class and type, with variability linked to differences in fire resistance and regeneration strategies. And much of the work thus far has gone into assembling this combined periodic and annual inventory database, which is exciting because it's going to provide a lot of opportunities for analysis in the future. And so we're planning to tackle the things like the fate of post-fire deadwood, understory vegetation trajectories, long-term, immediate and long-term carbon pool transfers, and post-fire fuels, et cetera. And while I focused on the Biscuit Fire today, we plan to expand this out to the 70 fires over Western Oregon and Washington. And what I've highlighted today really shows how the forest inventory and analysis program data can really offer a unique opportunity to compare post-fire landscape to what the pre-fire conditions were on the ground, with applicability to a rich suite of questions related to land management. And forest inventory data is really enhanced by supplemental fire effects studies, which provide a window into that immediate post-fire landscape. And as a lesson learned, I'll say that it's really important to consider both the short-term and long-term uses of any monitoring data, because you never know who's going to come along 20 years later and want to make use of the data you have. And also, with any monitoring program any potential protocol changes really should carefully consider the pros and cons, since that can really complicate analyses down the road. And finally, with this, we'd like to offer thanks to all who made this data happen, to Don Gedney and Dave Azuma on the FIA research team in 2002 who lobbied for the data collection, to Dave Cleaves and Sue Willits who funded it, to Terry Jane for supplying a field protocol that we could adapt, and all the crews who've collected the data over the past 3 decades. And with that, thank you so much, and please follow up with any questions or interest in the topic. We'd love to hear from you.
Now we have about 10 minutes for questions. We'll invite Madison and Liliana back up. So if you can move to a microphone in the room if you have a question, or yell from where you are. Madison?
I was curious of when you look at distance to seed source, whether if you look upslope versus downslope or to the predominant wind direction, whether you found differences there in the actual distance, and how, if so, whether that changed by tree species.
Yeah, so the question.
So we're going to repeat the question.
Awesome, yeah. So the question was asking about, so we looked at distance to seed source, but are there any other patterns when you look at whether that seed source is upslope, downslope, or in the direction of prevailing winds? That's not something we incorporated into our models, but something that I have thought a little bit about as, yeah, we know other factors like that do influence seed dispersal distances. But yeah, not something we explicitly incorporated into our models.
I have a methods question, kind of. When you're talking about seedlings per hectare per year, is that seedlings that sprouted in that year? How do you deal with seedling age?
Yeah, so it was a question about seedlings per hectare per year, and if that just includes seedlings sprouted in that year, and how we deal with age. Yeah, for the sake of the 10-minute talk, I kind of skimmed over some of those methods, but we measured 2 classes of seedlings. So seedlings under 10 centimeters in height, we just tallied the number of individuals by species within a half-meter radius subplot. And then for seedlings greater than 10 centimeters in height, we did actually count for each individual, record their species height and age using the whorl counts or bud scars on the seedlings themselves. Yeah, did that answer your question? Awesome.
I had a question about the understory work from the person in the middle. I'm sorry, I spaced your name. Did you look any at different life forms in your richness and abundance categories? I saw you had evenness, so you must have some sort of measurement of abundance. And can you talk a little bit about what sort of life forms you're seeing, if you're seeing any exotics, that kind of thing?
Yeah, great question. So to summarize, looking at life forms of the richness and diversity, and we did look at that. I did cut that out for the purpose of this talk. It did seem to vary with pre-fire stand age. So off the top of my head, I think in young stands, grasses were more likely to come back. In mid-cereal stands, I think shrubs were more likely to come back. In late cereal stands, herbs were more likely to come back, or like increase in relative abundance, I should say. In regards to non-native versus native species, it really seemed like it wasn't very prevalent for non-native species to be like, I would say like in full effect in a high severity stand. It felt like more like far and few between, so yeah.
Any other questions?
Do a follow-up on regeneration. Did you see any patterns in years after the fire, kind of using your seedling counts to get at that question of not just delayed mortality, but delayed regeneration?
Yeah, so the question is asking if we notice any patterns with years after the fire. I guess to clarify on your question, are you talking about like between 3 and 5 years post-fire, did we notice any differences in abundance? Yeah, so our Goodell Creek fire, we sampled at 5 years post-fire, and that fire tended to have like the highest species abundance, or sorry, highest abundance overall of regeneration rates. And you could see that between 3 and 5 years, like the height growth on some of those seedlings was pretty impressive. But in general, like no strong patterns between our 3 and 5 year post-fire. I'd be interested in returning to these sites, the same sites over years to get kind of answer that question better.
Thomas?
Past 5 to 10 years, it seems like there's been lots of papers kind of from around the western U.S. pointing out forests aren't recovering following fires. Doesn't seem like it's quite as bad here. Am I going too far out of saying that? Sort of give us some kind of ballpark assessment about where your all studies compare with some of the work coming out from drier interior western fires.
Yeah, that's a great question. So to summarize, how do the results we're seeing in Western Cascadia compare to some other systems in the West generally where there's documenting regeneration failure and whatnot? And I'd say, yeah, it's hard to say at 3 to 5 years post-fire. This is kind of a snapshot in that immediate post-fire window, but it's, from a first glance, pretty impressive how much regeneration we are seeing in this immediate 3 to 5 year post-fire window. And just for perspective, I think 85% of our plots met or exceeded forest practice minimum. So what Washington DNR at least goes out and their minimum threshold, our plots are exceeding that in 85% of stands. But be curious to see like track survivorship over time. But yeah, in general, I would say from a glance initially, it seems like Western Cascadia, they're coming back strong initially.
Yeah, and I'll just add as a component for the down in the Klamath, I think there's a large question in terms of when we have forest burn at high severity, whether it comes back as forest or if it shifts to chaparral, shrub-dominated chaparral. And I haven't gotten into that yet, looking at the Biscuit fire, but I'm really curious to see. I mean, I think we see some of the conifer stands persisting, but then, yeah, factoring in the competition with shrubs, it definitely will be interesting in thinking about effects on reburns. If you're likely to have a reburn happen again, is that going to just kill your seed source for conifers? So, yeah, definitely an interesting question. Thank you.
Yeah, and then to give a little plug-in for the complex early-seral forests, because it's so rare in this landscape, although the trees are coming back strong, it is interesting and important, I think, to have that complex early-seral ecosystem present to provide those really high biodiverse like processes, services, and functions that you can't necessarily get by just planting trees, let's say. So, yeah.
Time for one last question.
Hello. My question, maybe it's for the group or not, but my question is, were there any species or group of species that dominate the post-fire regeneration that have the potential of outcompete the establishment of the main tree species?
So the question was, were there any species that outcompeted establishment of
Post-fire
the dominant
regeneration
species?
Yeah. Thank you.
Were there any species in the post-fire environment that outcompeted the dominant species?
I mean, any species or group of species that maybe an establishing after the fire, maybe post-fire regeneration, that maybe they can outcompete the establishment of the main tree species. Basically like an interaction or something that maybe you see that maybe a shrub or group of shrubs or herbs that maybe are dominating after the fire in these areas.
Yeah, one example I feel like, and especially considering distance to seed source, where live tree species are really far away, and so that might be, confounding factor. But one shrub species that really came back strong is the Ceanothus genus in general. Really just sort of shaded out everything underneath to where there was really little conifer regeneration. But again, that could be due to distance to seed source and available seedlings. So yeah, I don't know if you guys want to add anything.
Yeah, and just to add to that, like it's interesting. Some of the plots we sampled at 3 years fire, like just for fun, have gone back 5 years fire, and it seems like things are rapidly changing in this like 3 to 5 year window. So where was I going with that? It'll be interesting to continue to like follow these forests and kind of suss out what like competitive dynamics are occurring.
Yeah, and I'll add to that while I don't have data for this yet, but talk to me in a couple of months or so, and I'd say the FIA data would be perfect for answering this kind of a question in terms of having real accurate on-the-ground pre-fire data and then being able to compare it later and see what we're seeing 20 years down the road, whether it has been outcompeted or not. Great question.
Thank you so much. Come find the panelists later if you have questions.